guys, so we're gonna start with, I'm gonna redo mixtures because mixtures is something I know is kind of mixed up. Kind of mixed up. You get kind of mixed up. Okay, don't worry about that. So we have solution, colloid, suspension. Solutions, no, it cannot scatter light. No, it will not settle on standing. No, it cannot be separated by filtration. Um, for scatter light, we have to think of it like by scatter light, yeah, it goes through, but like you have to think of like, will it bounce off of? If you see like it's not really bouncing off of this bottle, so no, this way. I guess that's what they mean by scatter light. So no, it don't scatter light. Then we have our mayonnaise, which falls under the colloids. Mayonnaise, right? This you cannot see through it, right? But it bounces off, and you can see it reflect. Y'all might think I'm crazy because I'm doing. Okay, you see how it reflects? Like the light reflects off instead of going through. See how it reflects off instead of going through. It's not real funny, y'all. It reflects off. And it doesn't go through. You cannot see it. But then when you do the water, like it goes all the way through and it doesn't reflect. So that's that. Um, so we have suspensions. So colloids, the soup, fog, and mayonnaise. The particle types are small clusters. Particle size is medium. The as you see, the mayonnaise can scatter light. Mayonnaise does not settle while standing. This mayonnaise is not old, and if I open it, I will not. Well, you see the spoon there, but I don't have to shake it up to use it. I can just take it out. Something that can be like that would settle while standing. Do I have something that settle while standing? Give me Let's see if I have something that settles while standing. So
The lady who lives next door to us is back. I should ask her if she want to buy some popcorn from me. Why this lady family member? She get the mail. She get the mail and back up in her own garage. She skipped the mailbox today.
I'm trying to find something that will settle while standing. I'm still looking. I found it. Okay, so you guys know that one of our examples were the Italian sauce. So now I have an example of the solution, colloids, and suspension. So this is our solution, even though it don't have salt in it. Our solution. This is our colloid, and this is our suspension. So we're gonna go through each one since I have everything down. We're gonna go through each one and sorry, I'm drinking the experiment. we're gonna go through each one and see like everything. So for solution, we have our water, right? Water is the first one. Particle types are atoms. You know, it's two H2O. So it's two hydrogens, one oxygen, right? Yeah, I think that's how it is. Two hydrogens, one oxygen, and um, yeah, H2O. Two hydrogens, one oxygen, and those are atoms. So the particle types are very small. The size is very small. And for scatter light, at least my definition of scatter light is like if you put a light up to it, it can't go through, but it's supposed to be able to like show like through here. So like this, right? It's lit. And then you see how it like goes through? So it's going through, but it's not scattering like on the bottom in a way, right? And then for our settle while standing, like nothing in here, anything that they put in here will not settle while standing. Like if this was a salt, the salt will not settle. Separate by filtration. If I pour the water into a strainer, it would not separate. So yeah. Next we have our colloid, which is the mayonnaise. Particle types are like small clusters, you know, like mayonnaise is like globs, kind of like, you know. And then the particle size is medium. So yeah, it can, like, the particle size is medium. Okay. And then we have scatter light. Like if I put the light up to here, you see how the light does not go through? No, it's in no way you can see the light. Is that light? I think that's something else. That might be the light. Don't worry, but like, oh, that's not this light. I was trying to see if it was this light. It's not this light. Yeah, it's that little thing right there. That's not this light, okay? But this is not going through. You cannot see this light. But if you do it here, you see how. Oh Jesus! I had this light for about a year now. But if you see, the light is scattering on the bottle. Next we and scatter light, yes. So yes, it does scatter light. Settle while standing. No, mayonnaise does not settle while standing. And separate by filtration. If I put mayonnaise in a strainer, it could be like you cannot separate all of the particles in it. Then they have Italian sauce. This is the Italian sauce, and the clusters are large because this goes under suspensions. The clusters are large. Clusters. The types, they have large types. The particle size is large. Scatter light. So we can do this again. No, the light does not go through, but it does scatter at the bottom. So you see that the light scatters at the bottom. Settle while standing. As you can see before, I messed up and shaped it up. All of the like the little things that's in the Italian seasoning, it falls to the bottom. Like some of it is still there, like you can see it, even though it's all over. But usually, I'm gonna leave it. See if they'll sell back real fast. But usually they'll be at the bottom like all the seasonings and stuff. And separate by filtration, yes, because if I pour that Italian sauce into if I put the Italian sauce into a strainer, you could like separate all the particles and stuff, possibly, depending on how small the strainer you have, I guess. No, any type of strainer should be able to separate it. But yeah, so those are our 3 examples. So you can see, like, you see like how it doesn't hold the light really, like the light goes through. Cause I didn't know if anybody like understood that. So the light goes through the whole bottle, it doesn't just stay right here. So it's not scattering from the bottle. It's actually going through. Particle size is key. Suspensions, mixtures in which insoluble particles are suspended in a liquid or gas. The tunnel effect, you can see the light pass through a colloid or suspension. Um, yeah. Um, Emulsion, a mixture of immiscible means cannot mix. Immiscible substances, immiscible substances like milk and mayonnaise. Um, Sir J.J. Thompson, this is where we were supposed to start out, but I just wanted to like go back into that so that I remember. Sir J.J. Thompson, yeah, let's not go into the plum pudding model. At We switched to the banana pudding model because if you say banana, you could say like because banana has so much M's, you could say banana and negative. So banana was the negative part, which was the outside, and the pudding was the positive part, which was the inside. Pudding positive, okay? Banana negative. Um, Polarized. Suspension settles to the bottom. Colloids or pudding helps hold up. And then you had your cathode rays and everything. The cathode rays, I don't know if you ever saw cathode rays, but it's like a weird looking bottle. It's like a small, tiny bottle. It's like that, and like it has the little things on both ends, and then it has the like a drip thing kind of like thing. But yeah. So a cathode ray is a stream of tiny negatively charged particles moving at high speed. Like if you've seen the bottle, right? I was talking about the bottle. But electrons must be part of the atoms of all elements. So those are just electrons mass is about 1/2000 the mass of a hydrogen atom. So electrons are very, very small compared to the atom. The electron lives inside of the atom. Deflection towards positive plate, this negative charge, sharp shadows, streams of particles. Okay, so now I'm gonna like, these are the last few pieces of notes before I finish. Yeah. So subatomic particles are protons, neurons, and electrons. Particles that compose cathode rays are negatively charged. That was made up in 1897. Negatively charged particles are electrons. That's kind of easy to remember because like protons, which we're gonna talk about, like protons are like a whole bunch of protons is what make up the nucleus, and protons positive, pp, positive. Atoms are divisible.
Hakuna Matata.
Atoms are divisible. Electrons comes from atoms and they're very small. Yeah. Okay, so electrons come from atoms. Atoms are very, very tiny. Like atoms help make up stuff. So of course, if they help make up stuff, that means that they would have to be small themselves. So that means that like the human eye would not be able to see an electron. Atoms are neutral, and we'll talk about later like why they're balanced, why they're neutral because they get like balanced out and stuff. So because they are neutral, they must contain positive and negative. Electrons are so small they must have more inside atoms to make up atoms. So I don't know if you understood how I said that. But because electrons are so small, that means it must be it has to have a lot of electrons inside of an atom, which was disproved. They were just those two that I just listed were just inferences. And another theory that was disproved was the banana pudding model. I know I told you about that. That was electrons are evenly spread throughout an atom to balance positive charge of the atom. It's like a watermelon and its seeds, like how the watermelon, you have the watermelon, but then you have the seeds as well. and the seeds are not just in there, but they're bounced around the watermelon. The alpha particle is positive particles 4 times the mass of a hydrogen atom. So the alpha particle is bigger than the atom. The nucleus in an atom is positively charged. It bounces off another positive positive charges, which are they're very small. Um, Later on, you'll see that the proton makes up the nucleus. It's like a big old cluster of protons makes up one nucleus. Um, so because the protons are positive, because the protons are positive, um, yeah, because the protons are positive, they can't take positive things. So like like they say, positive and negative things can attract positive and positive. They reflect from each other. So that's why like they wouldn't go together. If an atom were the size of a marble, so no, I didn't mean to put an atom. If if the nucleus, I meant to put nucleus. If the nucleus were the size of a marble, then the atom would be the size of a football field. So that means that the atoms is just that much bigger than the nucleus. Like protons are just that tiny inside the nucleus. So it's different things that make up the atom. So like that's why they say the atom is divisible because they have different things inside of the atom. Electron surrounds the nucleus. So like you could say like one electron surrounds a whole bunch of protons because protons are nucleus. Nucleus is the simple type of is the most simple type of hydrogen atom. Protons are the positive charge. Neurons are the negative charge. Um, and that's what the atomic nuclei is made up of. The neutron is neutral, just like the atom. How the atom is neutral because it gets balanced by the negative electrons and the positive protons. The nucleus is a proton, like I said, it's a whole bunch of protons combined together to make one big thing, the nucleus. The smallest hydrogen atom consists of one single proton, which is the nucleus, and an electron moving with. Okay. The protons are way bigger than the electrons, so that means that the electrons are even smaller than the protons. And you already knew that it takes a whole bunch of protons to make up one neutron. So the electrons are like even smaller than the protons. Simplest atom does not have a neutron. So if they ask you like on something like what is the smallest, like how much neutrons are in the simplest atom, it's none because there are none. Atomic nuclei of different elements have different numbers of protons, meaning they have bigger positive charges. So like the protons in elements, atoms and stuff, they have different numbers of protons. So if you put more protons together, it gives you a different element. And also mean they have bigger charges. So like I guess you would say like a truck or something like that, right? Something like that. But the protons determine the atom identity. So like how many protons there are in that atom, that means it's something different. Like just one more proton could change the whole thing of the atom. It's known as nuclear forces. More than one proton can be around the nucleus. Same with the neutrons. So that was it. Yeah, that was with that's all that goes along the protons. More than one proton can be around the nucleus. same with neurons. So that was known. That's also known as nuclear force, unless you didn't get that. Yeah, that's it.